And good afternoon. Welcome to the 9th and final seminar in the Synokisis Digital Classics Spring 2021 semester. This semester is themed on digital cultural heritage. And if you've followed any of the previous 8 seminars, you know that we've had strands on geographic technologies, on legal and ethical issues, and on 3D technologies. And this seminar is on 3D modeling. This is the third of the last of the 3D technologies strand, and we're very pleased this week to be joined by Alicia Walsh, who runs a company called Recollection Heritage, and Vasiliki Lagari, who is at the University of Leiden, and Chiara Piccoli, who's at the University of Amsterdam, all experts in different aspects of 3D. Themselves. So I think I will hand over there to them to do all the talking. Just a quick welcome to everybody watching. Anybody watching live, please feel free to say hi using the live chat feature. Also make comments and questions during the session, and at the end we'll have a bit of time for discussion. So please feel free to join in the discussion there in chat. If you leave any comments in there, we will see them and we will do our best to address them. Also, a hi to anybody who's watching this not live and who's watching this later. Please feel free to use this video and the session page supporting this video, which you'll find a link to beneath the YouTube video, and any of those resources in teaching or learning of any kind. This is all open material. We want as many people to use it as possible. So I think now I will hand over to Alicia, who's going to introduce the concept of 3D modeling. What are we talking about when we say 3D modeling?
Great. Okay, thank you, Gabby. Yes, I'll share my screen now. Oh, can you see that all right?
Yes.
Perfect. Okay, yeah, so I'm going to begin by talking briefly about what 3D modeling is, the different kinds of 3D modeling, and followed by some examples of why we would use 3D modeling in cultural heritage. And then I'll hand it off to Chiara for her case study presentation, and followed by Vasiliki on her tutorial. So starting off, what is 3D modeling? If you've been following our previous sessions, you will have already heard that we distinguish between 3D imaging and 3D modeling. So while 3D imaging is digitally recreating an object that exists in the physical present using either photogrammetry or 3D scanning, 3D modeling, on the other hand, is creating from scratch a 3-dimensional representation of an object that may or may not exist in the present. So some terms that you may hear when discussing 3D modeling, starting with CAD. You often hear CAD, you think about software used among architects and engineers, but it's really just the use of computers to aid in the creation, modification, analysis of the design. So some programs are AutoCAD, Blender, SketchUp. Yeah, and we're going to talk about Blender today later on. The next one we have is digital sculpting, which is also called 3D sculpting. It's often used by artists, and it refers to 3D tools used to sculpt a digital object. So you can manipulate the object by using tools that you would as if you were sculpting in real life, like brushes, and you can push, pull, smooth the object. And it's often used in video game design, movie animations, and so on. Then we have procedural modeling. This is a term that encompasses a number of techniques that create 3D models and textures from a set of specific parameters. So it applies an algorithm for producing a scene rather than assembling objects using generic tools such as cubes, triangular faces, and mesh. We then have virtual worlds. These are computer simulated environments. They're often populated by users with their own avatars who can explore their environments and interact with others. And some examples of these are Sims, Second Life, Minecraft. But it's not only used for games, they can also be used for virtual conferences and chat rooms. And finally, we have real-time engines. So these are game engines that make 3D models interactive and animated. It allows you to see your model in a virtual environment and allows you to move fluidly through the model and look in any direction. So it's often referred to as a first-person perspective or a first-person shooter in video games. And some popular programs that use this are Unreal and Unity. So this isn't a comprehensive list, and there's always new technologies arising all the time. But why would we use 3D modeling in cultural heritage? So many scholars have already recently pointed out that there is a lack of consistent archaeological projects using digital applications to answer specific research questions. Many projects are more interested in disseminating their findings using digital applications instead of using them to conduct the scientific research. So that's not to say that using 3D modeling for communication and public outreach isn't important. It definitely has its place, but there are also many other reasons that you could implement 3D modeling. So each researcher and research project is going to have a different reason for using it. And Chiara will show her example and why she used these methods, and Vasiliki will also give a demo on how to implement this for an entirely different purpose. But some other reasons that could revolve, some other reasons could be testing of hypotheses, which could be difficult or impossible to test in the real world. So for instance, you could test light and shadow or planetary alignments in relation to structures, or lines of sight. So for example, if a sacred site was near a domestic space, were those spaces visible to each other? And did that visibility impact the way people interacted or felt with these environments? So you can test that out through 3D modeling. And this photo is of the Roman villa of Aiano, which was from a project in which they used a combination of photogrammetry to model the existing remains of the building with 3D modeling to reconstruct the building in its entirety. So by using these two techniques and overlapping the digital replica with the reconstruction, they could make real-time hypotheses of dimension, orientation, and height, which helped them analyze where different architectural elements may have stood and different phases of the construction. Also, different versions of the reconstruction was made, and they were able to determine which digital reconstruction was more reliable. So, yep, as I said, there are many reasons why you would use 3D modeling in cultural heritage. So I think we should go straight into hearing about another one. So I'll hand it off to Chiara.
You're muted, Chiara.
I'm back. So okay, so I'll show you my slides. In this presentation, I'll briefly talk about my ongoing research on a 17th century Grand Canal house in Amsterdam as part of the Virtual Interiors project. In this case study, I use historical and archival sources to investigate the domestic consumption of cultural industries in what used to be the house of Peter de Graaf and Jacoba Bicker on the Herengracht 573. Both were members of very important families in Amsterdam at that time. And the overarching research question that I'm exploring deals with how and where paintings and books were kept, used, and experienced within their home. To this end, I use 3D modeling as a tool that helps me to think about, try out, and visualize alternative hypotheses on the use of space, and that allows me to virtually materialize these objects within the house. In this presentation, I'll talk about the work in progress on two aspects: the spatial distribution of paintings within the house and the reconstruction of the private library that de Graaf had in one of these the rooms in his house. There are four main underlying themes that I'll touch upon during my talk. First, I'll show you how I use two different 3D visualization modalities, one schematic and grayscale, and the other one aiming towards photorealism, to reconstruct the domestic space for different research purposes. Then I'll explain how I went about modeling the hundreds of books that are within the library, so quite a challenge, as you can imagine. Next, I'll talk about how I'm using the reconstruction as a research tool to investigate how many books would fit within the available shelf space. And finally, what I'm doing to document the reconstruction process and how we are planning to make the 3D models and data accessible. As far as which software packages I'm using, I mostly work with Blender, and I then used Mushroom for image-based modeling. So I'll show you how I used it to model in high detail some of the books that I then imported in Blender, and with MeshLab for some of the 3D processing and editing of the meshes obtained with image-based modeling. But I won't cover this aspect in this presentation. First of all, you may ask why this case study. Because of the unique combination of data available, which consists of a rich archival documentation, most notably the probate inventory that was drawn up upon the Graf's death, which contains a detailed record of the furniture and objects he had in his house, and his almanacs, which he kept for over 40 years of his life, and where he noted down all the things he needed to remember, which for us is a very interesting source of information regarding the construction and decoration works happening in his house, but also, for example, about which books he lent or borrowed. The other very important source of information is the building itself, which until last year hosted the Museum of Bags and Purses, now unfortunately permanently closed as the result of the Corona crisis. Despite having been heavily modified over the century, the building still helps us to derive the volumetric properties and internal arrangement of the original 17th century house. Some building plans from 1974 that you see in this slide, made available by the Amsterdam Monuments and Archaeology Office, have given me a useful starting point to familiarize with the building structure, since they record some of the changes that the house underwent. For example, as you can see in this image, doorways that have been walled up at a certain point in time, which therefore changed the navigation route through the house. Together with Gabri van Tussenburg, who is building historian working at the Municipality of Amsterdam and professor of urban identity and monuments at the University of Amsterdam, and Bart Rovekamp, who used to work as junior researcher in our team and helped me also with the archival research in the Rich de Graaf family archive, I went to visit the building several times to double check the plans and to start to reconstruct the original room partition and navigation route through the house as much as possible, and to correlate the rooms listed in the inventory with their possible original location. And this is an important but challenging process. In fact, for some of the rooms that are listed in the inventory, their names clearly indicate their position within the house. For example, the Ford house is unmistakably the entrance hall. But for other rooms, like, for example, here, there is a Groene Kamer, a green room. So the name itself doesn't give any clue for identifying their location. For this reason, the reconstruction process is very useful to be able to work out their location within the house. Based on these observations, I digitized and re-elaborated the plans in AutoCAD and imported them into Blender to reassemble them into the 3D frame of the house and to proceed further with a more detailed modeling of some of the rooms. So the models that you see in this slide, but also in the next slides, are the results of this multi-source approach that I just described. The first application of this schematic grayscale model of the entire house, once I derived the disposition of the various rooms, has been to start investigating the presence of paintings, their subjects, their values in relation to specific rooms of the house. The aim of this work is to facilitate an overview of the distribution of paintings, to distinguish between those that were on display in more secluded and private spaces, and those that were meant for a wider consumption. We don't have time to go into detail on this, so I'll quickly show some preliminary results just to give you an idea. And we can go directly to the second floor, which is where the library was located, between the Groene Kamer that I mentioned before and the largest room, the Grote Kamer, where the majority of paintings are located, especially family portraits. So this room has changed so much that it's currently barely recognizable as being originally, first of all, a separate room, because as you can see in these pictures, part of its walls have been demolished, and definitely its original function was completely lost. So no one knew that the Graaf had his library in here. So this research was instrumental to make this visible and to bring this back. And as it is usually the case, the creation of a 3D reconstruction has become the occasion to revisit old data with a fresh look, or like in this case, also to collect new ones. And in fact, the creation of this 3D reconstruction has prompted me to investigate which books were kept in here to reconstruct not only the physical space, but also the actual content of his book collection. And to do so, I'm relying on several sources, which turn out to be more abundant and much richer than I could imagine. So this room and its content have become a sort of a case study in its own right within the case study of this house. And particularly interesting is that I could retrieve the Graaf's book auction catalog, of which the only surviving copy is currently kept at the National Library of Russia in St. Petersburg, which listed more than 2,300 books. So he definitely had a large collection. The research questions that I'm currently investigating are, would all these books fit within the library room? Or should we think about other places in this or other houses where part of his book collection was kept? And this is a provisional 3D reconstruction of the library, which depicts it as I envision it at an earlier stage of my research. And in the meantime, I made progress with my research. And now that I know more about the Graaf, his interests, and this subject, my ideas have changed. So I'm working on an updated 3D reconstruction, especially for the dimension of closet, which I'm making bigger, and the appearance of the bookshelves. What I'd like to show you now is a bit of the behind the scenes process of making the 3D reconstruction by talking about two different modeling strategies that I used for the books. For a few books, which I placed on top of the closet, I used Mushroom to create high-resolution 3D models from images of some books similar to those that the Graaf had in his collection. And for the hundreds of books on the shelves, I used the trick that I'll show you in a minute to keep the polygon count low, so that the books look realistic, but they aren't computationally intensive to render and can be used for real-time interaction in our web viewer. And I'll come back to this later. Here is the Mushroom workspace while the images are being processed. And on the right of the slide, you can see the resulting 3D model that I also uploaded on Sketchfab. So if you can download it from there if you want to play around with it. And I also added a short tour around this book with some additional information on it and the link to a digitized copy if you want to have a look. And here you can see how this book looks when imported in Blender, together with some other books that I modeled using the same technique. Their meshes are quite dense. So in Blender, you can use the modifier Decimate to reduce the number of polygons that the mesh is made of, without compromising the look of it. And Vasiliki will show you another couple of modifiers that are very useful in her tutorial. So you can see in this example that the number of faces has been considerably reduced without noticing any difference on how the book looks. As for the handmade modeling of all the other books, as you can see in this short video, I just used pictures of books on the shelves of the Tiziana library in Leiden. And the Tiziana is a rare example of a still preserved 17th century library, as references to model a simple geometry, and then used the same pictures as texture images. So the book look still good, even if the geometry is very simple. And I take this opportunity to thank also Paul of Theiser, the curator of the for allowing me in and for his advice during this research. Besides making a forgotten function and a history of this room visible again, I'm also using the 3D reconstruction as a tool to estimate the available shelf space, and therefore the number of books that it might have contained. To do so, I measured how many books of which format fit on the shelves of the Tiziana library, and then I extrapolated the number of books that would fit in this reconstruction now that I have an hypothesis on the available shelf space. As a provisional result, I can say that just over 1,000 books would fit within the reconstruction hypothesis of the room, so less than half of the books there are listed in the Graaf's auction catalog. Of course, there are several caveats related, for example, to different types of formats and bindings that the books might have had, which would have an impact on the amount of space that they occupied. This information is interesting because indeed the research I'm carrying out on this library is showing that there were other locations in the house and other houses as well where the Graaf and some of his family members kept these books. So we shouldn't imagine that all the books in the auction catalog were in this room. Moving on the last theme, despite the richness of the data set on the Graaf's house, there are many things that are still uncertain. And in any case, these reconstructions visualize my interpretation of the data. Moreover, there are objects that are used as proxy for the objects listed in the inventory when the original has not survived or I haven't been able to identify it. And so all these choices and interpretations need to be accounted for. And in fact, one of the core aspects of this research and of our project in general is to express this uncertainty and expose the behind-the-scene process of data collection and interpretation that led to the reconstructions that I'm making. I haven't yet completed this work for the library, so I'm showing you what will come with another room of the same house that I've completed, namely the entrance hall, which was located actually just below the library. I made the 3D reconstruction that you see in this slide based on the same combination of sources and using the same modeling techniques that I talked about in my presentation. And as you can see on the right side of the slide, this is how I'm keeping track of my decision-making process, the sources that I'm using, and the uncertainty of the resulting 3D reconstruction, which are then visualized in a color-coded scheme. All of these models and underlying data sources are then combined and visualized in the prototype web viewer that my colleague Hugo Hurdeman is currently designing and evaluating within a project. This web viewer allows users to explore the 3D reconstruction, the underlying data sources and linked data sets through semantic queries, and to visualize the uncertainty both on a desktop and with a VR headset. And in conclusion, just a few points of discussion. So what I wanted to show you in this presentation is how the 3D reconstructions that I'm preparing act as virtual laboratory. For example, to visualize lost building phases and room functions in a non-destructive way, and also in a way that makes it possible to update them when new data or interpretation become available. And also laboratories to materialize household objects in their spatial context, to expose associations of objects and correlations of objects and locations which were previously not so evident, to investigate spatial properties, visual prominence, and agency. And this is an aspect that I investigated, especially with a case study on the Ford House, on the entrance hall. And finally, to structure heterogeneous data and make them accessible, in particular with the aid of the web viewer that I mentioned before. So thank you for listening, and I'll give the floor to Vasiliki for her tutorial.
You're also muted, Vasiliki.
Hi, sorry. Okay. I will be the practical part, I think, of this session. And the students have already been provided with the manual that you're going to work for the class. Can you hear me? Okay.
Yes, yes, we can.
Okay, perfect. But before I start, I want to show, because I have already calculated the time that I need to explain the whole manual, and it is much more than the time that we have here available. So I prepared a very short PowerPoint that will show you the main stages. Of course, after that, we will make a very short introduction for the scaling of the images, which is always very confusing for some of the students. And I think it is a very good start. And then you can continue, of course, on your own, and I will be of help through your messages. The manual was developed during my internship under the supervision of Dr. Chiara Piccoli and Dr. Janita Vroom in Leiden University. And the object used, there were two objects, but the main one here for the manual is a cooking pot from the early Islamic, late antiquity, early Islamic period, coming from Oman. And it was brought by Dr. Franken during the 60s or 70s in Leiden University. So here, what we're going to do is reverse engineering, actually. What I did in the internship was I scanned the real object, and then I made the profiles from the real object. So here is the cross-section. From Adobe Pro DC, I imported the model there, and then I cut it in half. And I imported it in Blender, and from that, I reconstructed the vessel. But as you can see here, the real vessel, what we see here, the real vessel was half. It was semi-complete. It was half preserved. Therefore, we had to look in the bibliography in order to find a parallel, the most accurate parallel that could be found. And it was added also during the process, and I could have in the end the vessel. Of course, the level of transparency, I don't know, I mean, how accurate it is, but it is as accurate as possible. Of course, this is always a risk. So the first thing that we do is to import the image with of course a reference measurement. So we need to have a measurement that it is accurate, and we can have later accurate calculations. Here the next step is to add the profile and align it to the real profile, in order to trace both of them and make the 3D reconstruction. And from here, we start reconstructing by adding vertices. So we add vertices and we make the outline of the profile. You can choose every side you want. I chose this side because it seemed that it is more accurate. As you see, the profile, the parallel profile is symmetrical, but the object, the actual object is not, maybe due to manufacturing reasons or to deposition reasons. So I selected the side that seemed to be more aligned to the parallel. And then when I created the outline, I used the spinning command and the lathe technique. And I made a complete rotation of the vessel. The next step was to create the handle with using the path curve. Of course, there are other ways also to create a handle. There are many ways to create every step that you will see in the manual. But this is what I'm using, and many of these ways also are inspired by the manual that we had during our course with Dr. Piccoli. The creation of the handle was for me the most difficult part because it was very hard to, after its creation, to adjust it on the vessel and make it appear seamless. And here is the end result. By selecting the half of it, I mirrored it. There is the symmetrize option or the mirror modifier. And I had the symmetrical cooking pot as complete in its entirety. And the last step was to calculate the volume. So in order to calculate the volume, I don't need the exterior part, I only needed the interior part of the vessel. Therefore, I selected the interior part and I duplicated it and transferred it outside of the main vessel in order to calculate it by a specific add-on that you will find on the manual. So now we'll move very fast. I don't also know how much time I have, so you can, Gabriel, you can tell me when it's so.
You have about 30 minutes starting now.
Ah, okay, great. So I will show you now how to scale your images in Blender and how you can start with the tracing. So when you open the software, this is the first image that you will see. You can click anywhere on it and it will disappear, and then the default cube will appear on your screen. Very few tricks. It is good also before you start to watch the videos that they are recommended on the tutorial, and of course you can search. There are thousands of them online. Everything later 2.80 and later versions of software of Blender will be accurate. So I will very shortly show the interface. This is the 3D view report. This is the 3D viewport. This is where the whole modeling happens. These are the menus, and these are the different workspaces. Mostly I use in this one or the sculpting one. These are the tools panel that of course change if you change from the object mode, and let's say we go to the edit mode. This is the outliner window, and this is the properties editor. In the outliner window, we can see the objects that we have in our scene. So right now we have a cube, we have a camera, and we have a light. And by toggling the eyes, we can activate them and deactivate them, make them visible or not. By clicking, left clicking on the object, we activate it, and from here we can go to the edit mode. In the edit mode, we notice that we have the structural parts of the object. So if we click here, we have the vertices. With this icon, we have the edges. We can select by clicking on them the edges. And here we have the faces. These are the structural parts of every object that we will add. The edit mode, of course, is not available, let's say, for images or for the camera. So mostly it is for the 3D objects that we will manipulate or create in Blender. At this point, I have to say that in Blender, it is very good, and this comes, of course, with experience and with time to use the shortcuts, because it makes the work more efficient and much faster. So instead of going every time here and change to object mode, we can just click Tab. Tab is the shortcut for interchanging between edit and object mode. Now I'm here on object mode. And I think I said, one more thing before I start. In case that some of you do not have a numpad on the keyboard, you can go here to Edit, Preferences, Input, and you can click on Emulate Numpad. If you do that, then by clicking 1, 2, or 3 on your numpad, you have front orthographic, right orthographic, and top orthographic. views. For those that they have a numpad, these numbers are 1, 3, and 7. And one last thing is the navigation, of course. So if we click the middle mouse button, we just rotate our, we are in user perspective, you can see it here, and we rotate around our scene. If we click Shift, if we click Shift and the middle mouse button, we can pan around. The same we can use by clicking and drag on this icon, drag on the direction that we want. And if we want to zoom in or zoom out by scrolling our wheel, we can achieve that, or by clicking on this button and drag. So I think now that we have said most of the introductory things very, very shortly, by pressing 1, we are going to front orthographic. I will keep the cube here, but I will just make it invisible. And I will start by adding my 2 images. So I'm going here, add, image, background. And of course, for every one of you will be different. I'm going to the directory that I have saved the material for the manual, and I click on Profile Scanned Object. And I load it. So here I can see it. And I can see also the measurement, the reference measurement. Just give me a second. Yeah. So if I click on the measure tool, I click and drag and make the same line. And I see that here I have an indication of 3 meters, 3.8 meters, which is very unrealistic. Therefore, I go to the scene properties. I go to the properties editor here. I go to units. I select metric. We want meters. I select degrees. I make sure that everything is all right. And for me, it is always helpful to turn it to centimeters. If you can turn it to millimeters, it depends on the object that you want to have. And it's turned automatically. And it is imperative, of course, here to change the scale. How I'm going to do this? There are 2 ways. I will show you one which seems to be more understandable. The second way, the less understandable, is to apply the rule of 3. So you have the dimensions here, you have the real dimensions, and you have the unit scale one. So you find out by the rule of 3, the mathematical rule, the scale that you need to apply on Blender in order to have the dimensions that we want. But I will explain it in a different way. So here we will activate the cube, and we will select it first. We will go to edit mode. We will go here to the viewport overlays, and we will click on edge length. Now we can see every edge, the size of it. It's on phase, sorry. So here you can see that every edge is like 200 centimeters. So every edge is 2 meters. We want every edge of the cube to have the measurement of the reference. We want every edge to be 25.2618, 25.3, let's say, centimeters. In order to do that, we click N on our keyboard, and we have this window opening. We turn on object mode again. And from here, we will change the dimensions. These are the dimensions of the cube, as you see, X, Y, Z axis, 200 centimeter each. We will change it and we will replace them with the value of the object. So I do that for, oh, sorry. Sorry, yeah. Now we see that our cube is very, very small. It's smaller than it was before, of course, because we changed its dimensions. But due to that, the scale also is changed. So Blender understood that since we changed the dimensions, also the scale is changed. But we want to make these dimensions as one-to-one scale. How are we going to do this? We press Control A, the shortcut Control A, and we apply these dimensions to scale. So now these dimensions are one to one. These dimensions are now for Blender like normal one-to-one dimensions. In case you want to apply the rule of 3, of course, you just replace it here, or here, or you can just replace the unit scale here. Now, since we have this cube with the real value of our reference measurement, we will scale our image, this measurement, to align, to fit exactly on the upper part of our cube. In order to do that, we click, we click on our object, and here we see there are these handles appear. We click on them, we shrink it, and then we select it, and with G, which is the shortcut for move, to move our object in the 3D area environment, with G and by clicking also the axis. So GZ to go to the Z axis, GX to the X axis, and GY to the Y axis. I can move it close to the cube. Here now I have I zoom in. I need to make it smaller. I will not be very detailed right now because we don't have much time. More. Okay, I think that we are good. We can use the measure tool just to double check. And I think we are good. A little bit more, maybe. Anyway, I will leave it here because we are losing a lot of time. So now our image is scaled, and we can now deactivate again the cube. Now we know that the image is scaled, and whatever measurements we do, they will be accurate for the future. And what we want now is also to add the second image, the profile. I make the same process, the same steps. So image, background, and I add the parallel. And I load it. And of course, our object disappeared, or we can just see its outline. So we will change the transparency by going here to the properties editors and to the object data properties. I click on the opacity and I just make the opacity less. I make it more transparent. At this point, maybe it is good to mention that I can change the names here in the tree in the outliner window. I can make this, let's say, parallel. Profile. Oh, sorry, no. Scan profile. And this one, parallel profile. It's good always to give meaningful names. And I follow the same process by scaling it and align it, fit it in the best way. On the main profile. Oh. See, this is a time-consuming process. You have to be accurate. Yeah, it takes some time. A bit more, I think, enlargement. Yeah, I think this is here the best. Yeah. Oh, sorry. So somehow, yeah, I need to, yeah, you need to dedicate some time in order to find the best. I'm not sure it's the best now that I have achieved, but I'm a bit limited by time. So, but you will have more time in order to adjust it, at least at this side. Because it is more accurate on this side, the object was somehow distorted on this side, so the profile is much bigger than the normal one. And so how now you start tracing the object? We activate our cube again. In order to start creating an object, we have to have an origin point. All the objects, the 3D objects in Blender, they have an origin point. And we want actually to create a new one, so we have to steal somehow, in brackets, the origin point of another one. So we're going to use the cube for that. We click Tab, we turn it on Edit mode, on Vertices mode, and we click A. With A, by clicking A, you select all the vertices or edges or faces, whatever mode you are in. And we click Delete on our keyboard, and we delete the vertices. The space, the geometry of the object has disappeared, but the origin point has remained, and you can see it here. This orange dot is the origin point, and this is the cursor. So now I will move my cursor. I want to start my tracing from here, and then I want to go up here and go back to the outer profile in the middle. In order to do that, I want to put both my cursor and my origin point here. Of course, you will see that during spinning you will change that. In order to move my cursor, I can go here. You click on the tools panel. You click on cursor. You place it on the point that you want to start the tracing from, and now by Shift S. No, you go to object mode, I'm sorry, and you click set origin to 3D cursor. So now you saw that the origin point from here, it went to the center of the 3D cursor, and now you can start the tracing. In order to start the tracing and add vertices, the first structural parts of your, the main structural parts of your object, you click Control, Shift, and right mouse button, but of course you have to be on edit mode. Control, Shift, and right mouse button. Control, Shift, you keep having it pressed. And, sorry, we keep, oh, sorry. You leave them Shift and middle mouse button to pan on the next part. Control Shift again, right mouse button. And you repeat, you do the same process until you have the whole outline until here. So this is the part that I will, so you have the interior and the exterior of the object, and then what follows after that, it's easier. I don't think that we have time to show everything because I have to trace the whole profile, but I think that the difficult part was this one, because it was difficult also to understand how we're going to scale and to orientate yourself in the software. So I think this is enough for now, and of course I will be available for any questions also while you are doing the manual at your own pace.
So just to thank you. Just a thought, Vasiliki, is the spinning a very easy step?
Yeah. It is very easy. It is just a button, and you just click the degrees. So it is very easy, and you can do it manually. It is actually very easy. I think the most difficult part is what I saw. That's why also because the aligning factory part, I thought that this is most important.
Okay, because I thought, I mean, if you could very quickly, you know, even if you traced it not very accurately and then quickly just did a spin, that might just be, you know,
yeah, of course,
I will think completed. I don't know how quickly you think you could do that, but if you want another 5 minutes to do that,
yeah, I don't know if it will be very very nice, because I haven't adjusted my profiles very well. That's why
Sure.
I wanted to avoid it, but I can show you without having done it that when it is ready, you just go to the, you see also here the points that I have already made. You click on 7, so you go to top orthographic. You click on 7, you go to top orthographic, and then you go to spin, and you spin around, actually either manually or by here by the window. You just insert the degrees that you want, and you will have the whole rotation, or half of rotation, or 1/4 of the rotation. So actually it is, as you see here, I rotated this in 185 degrees, the points that I have already made. If I go now to 1, of course, you see just a very small part of it. So it is not difficult at all. It is not complicated.
Great. Okay, lovely. That's fine. And all the rest of your instructions are in the manual?
Yes, everything is in the manual. So after the spinning, actually the object is ready, and there are some how can I say that? There are some, let's say, small editings to make the surface a bit smoother, let's say, but this is very, very easy. And then it is to calculate the volume, which is also an easy part. The only difficult part somehow is the handle. If the students want to try it, they can. It's difficult to adjust it on the vessel. So this is a different process. I know that some students, most of the students actually, we always in the tutorial come to this part before the spinning, and then they all send the manual actually back with very few questions, I think, because like after they do that, the rest is somehow easier. The only difficult part, maybe it's the handle, but they all try, and most of them, they do it really well. Great. Yeah.
Cool. Good. Well, there's a challenge for anyone who wants to do this in the future. That
yeah.
It should be easy.
And I have to say that this was all initiated by the manual that Dr. Piccoli had made. So I mean, it is not originally all mine, just parts of it and the concept of the internship. Cool. Yeah.
And Vasiliki's manual is downloadable as a PDF from the session page, which again, there's a link to both in the live chat and beneath the YouTube video. And there's also the 2 images that she showed are both downloadable from there as well. So if you want to try this exercise out yourself, you've got all the material you need to do so. Great. Cool. Lovely. Thank you. Does anyone else have any comments or questions they want to throw in now?
No, I just wanted to say thank you for that. I'm really looking forward to following through that tutorial myself and getting to know it. So thank you.
Me too.
Cool. Good. Excellent. A note also, anyone watching live, please do ask any questions, either specific or general, theoretical questions about this. We'll keep an eye on the live chat for any such questions. So we can ask questions of each other and talk among ourselves for the in the interim. I was struck by both case studies, the calculating the volume of a jar and figuring out how many books you can get in a library. That they're both quite specific, quite complex sort of mathematical calculations you do based on a series of assumptions of, you know, the size of the bookshelves, the size of the jar, etc. And in both cases, the reconstructions you build at various points, you know, have either, you know, errors which we smooth over, or estimates that we put in, or, you know, asymmetry that we're going to pretend is symmetrical, or, you know, all those sorts of things. I wonder to what degree that that makes your estimates less accurate, and to what degree you care about that, to what degree you're worried that, because it's not going to make it an order of magnitude inaccurate. But so I wonder if either of you had comments on either mitigating or just saying actually it doesn't matter.
Yeah, no, I think it's a very good point, because in fact, as I showed, yeah, there are a lot of uncertainties and still things that I have to work out. And for me, the reconstruction and the idea of trying to see how many books would fit in it, it's more of a tool for thinking. So I'm not looking at the exact numbers, but I think it's interesting to see, okay, there was half of the numbers of the books that he could, so not 50, not 2000, you know, it's like I'm not really calculating like really the precise numbers, but it gives you more an idea about, okay, then maybe I should search for additional sources, maybe I should look at the data at a different way. So for me, it's more on this sense. I'm not really claiming, okay, this is how it looks, this is how many books used to be in there, but it's more something that really helps me to build up my arguments. Because interestingly, I'm really looking at this archival sources and the Graph's almanacs. And for example, now I was looking at reading the almanacs, and I just found some entries where he says that he took books from his brother's house, and he actually says how many he got of different formats. So that I'm thinking, okay, well, at that point in time, I'm sure that he got all these more than 400 books from his brothers. So he must have been, and he took them in his house. So then they must have been somewhere. So it's like, you know, bits of evidence that you take from different sources, and it helps you to build up your argument and your hypothesis. So that's how I'm looking at these tools.
Yeah.
Yeah, I forgot again to unmute. This is also, I think that I can also relate to that question very much, because also my thesis is about symmetry and asymmetry, and it is about asymmetrical objects. And there are a lot of software for archaeological pottery online, but they only serve symmetrical objects. So you enter the profiles. Usually the profiles are coming. You have one profile for every object, and there are inaccuracies, and many of them, especially the handmade ones, they have different dimensions in different parts of them. So these applications can only work accurately for symmetrical wheel-made objects, and this is, I think, where software like Blender in combination with 3D models come, and they can give you more accurate, I'm talking, of course, for the pottery objects, more accurate measurements, because with a real 3D model, you can also have some more accurate measurements. So yeah, this is what I can contribute.
And I suppose you could, for example, calculate the difference between an ideal 3D symmetrical model and the actual model. I mean, how different actually are they from the ideal?
Yeah, because you can run statistics, and you can see like the deviation and the error, and it is always good to make continuous calculations, so you can see how precise also the method is. And yeah, of course, it is possible, and this is actually how you can, in digital archaeology, reach scientific results. Yeah.
Yeah. I've spoken to people who are interested in using this sort of method for calculating the volume of storage jars of amphorae, of which we know there were 1,000 amphorae on this in this particular site. How much wine was there, or how much olive oil was there in those circumstances? This is a lack of archaeological imagination on my part, but for a cooking vessel, as you said, this one was. What does knowing the volume of it tell us?
For this, it is about 8 liters. This one, but this is also a good point, because volume was very under researched so far. So most of the research was focused on the size or on the decoration. But actually, by knowing the volume, we can also have information about the economics of the society. Consumption, trade. So I think it becomes more and more important in the research field. Yeah.
And I think also, it also depends on what are your margins, in the sense, does it really make a difference if there is 1 liter more or 1 liter less, if based on your research questions? So that's also, this also has to take into account. There are always indication, there is always estimates going on, and it depends if it's interesting for your research purpose.
Yes,
right.
And I guess you have to think what an 8 liter cooking pot can produce. I mean, the pan that I use to boil my pasta in is 2 liters. So I'm thinking that's 4 times the size. That's a big cooking pot. Yeah.
Exactly.
Anyone else want to ask anything? I won't monopolize the question asking. Or I can do, as there's no comments in the live chat yet. So I was wondering, we've been talking a lot in this semester about ethics and intellectual property and so forth. And one of the discussions that has come up in some of the earlier sessions was about the argument that 3D images, so made using scanning or photogrammetry or similar, of an object that is in the public domain ought to be in the public domain, right? The 3D image of it ought to be, because it's a representation of an object that nobody owns the copyright of. It's a heritage object, it's an ancient object, or whatever. To what degree can the same argument be made, or would you say the same argument could not be made, for a reconstructed 3D model of the kind that you've both made? To what degree is that a mechanical representation of a heritage object which is in the public domain, and to what degree is it your creativity that has gone into making it, and therefore that intellectual property would arise from? A big and provocative question, I know.
Who wants to go first?
I'm not sure.
It's a very interesting question. I will have to think about it, to be honest. I don't really have an answer at the moment. For me, there are 2 different types of objects. So I also worked a lot with, in fact, as you saw, with 3D imaging. And I could, although for many of them, I make also my own changes. So then I sort of change them to be in line with, for example, the materials. So for a table, I could take a table that exists, but then apply a different textures, made different materials to, because in the inventory I have a specific material that I have to comply to. So it's like, there are several layers of also modifications that I'm making on these models. And then I have the models that I made completely from scratch myself. And from in that sense, I think I'm also thinking that some of them I can definitely share them. So I wouldn't have any problem with that. I would like that people would cite, or at least, that somehow, because of course there is a lot of time that you spend into making these 3D models. So I guess at some point, in some way, it would be nice if this would be also recognized as a sort of authorship. yeah, so that's my thoughts at the moment.
Yeah, I guess Vasiliki, like, would you have to attribute the 2D drawing in your research because you're modifying that? Or?
Well, I don't know. I think that every time that I need to give this tutorial, or like here now, I have the feeling, and I think this is the right thing also to say, that the context of that, like who offered you to do this project, and to where this object belongs now. Things are much easier, I think, when everything is published. So I guess when you make a reconstruction of a temple that has already been published, and there are many other reconstructions online, I think it is much easier to, and not so much censored or judged, let's say, to do it. But when it is a material that it is not published or still under research, I think this is where you have to be a bit more sensitive. I mean, I wouldn't dare to take the material now that Chiara has and just do maybe a different project, but just use it right now until she finishes, I guess. Like, this is, or maybe I can use it in a presentation by just offering credit. So I think it is a bit, on any case, it is different. I don't know, like what, it's a bit weird and sensitive.
Yeah. I think that also makes it very complex. The fact that there's a variety of cases and and applications. So, and also this field of publishing 3D models is also quite an uncharted field so far. So that's that's very interesting to think about.
Yeah, and so I think what we're seeing is that there's a complex network of different kinds of rights that we're talking about here. And the strict copyright, which I think it's probably fairly unambiguous that if you have created this object rather than simply, software creating it from a photograph, if you've had any creative input, you've chosen the parameters and so forth, then you own the intellectual property on that to the degree that it's a model. You may not own the intellectual property on the original object that it's representing. So, it would be complex if you were creating a 3D model of Batman, for example, that someone owns the intellectual property to the original figure, but you would nevertheless own the model because you made that. Then there's the second level is academic nicety or rules that, if you create this model based on the archaeological drawings and you don't cite them in your thesis, you've committed an academic fault. You may not have broken any laws, but nevertheless you can be penalized academically for it, or you'd be at least criticized by your peers. It's that sort of level. And then the third level is the ethical component, where probably neither the house in Amsterdam nor the Greek pots have this issue. But if this were a heritage object from an indigenous community for whom this object was sacred and needed to be, so for example, if you'd created a 3D model, a new reconstruction of one of the moai from Easter Island, say, there's an element of the community that own that and that consider that sacred, and that the parts of it that were underground were not supposed to be seen, and yet you've made a model which makes a reconstruction of them visible. So there's an element there of there's nothing illegal in doing that. There's nothing either academically improper in doing that, but ethically it's there's an issue that you have to think about when you're making that sort of decision, and all of those intersect with one another.
You have to be very careful. Yeah.
I've quite blithely said that neither of you have that third issue, but I'm sure I'm wrong. I'm sure you have considered ethical issues in your work somewhere.
Personally, I haven't so far. I was not involved in so many projects as Chiara, but I haven't so far. I don't know if Chiara has encountered.
I think it comes really well. But at the moment when you publish something and you put it out there, and then you really have to think through all these things and to give credit and to see actually if there are issues with maybe institutions where you took the also the original objects. So definitely these are things that need to be clarified before. Yeah.
Is there any issue with the ownership of, for example, the family or the foundation that owns the house? I think it was his name, De Graaf.
So well, it has been quite an interesting story because it used to be until last year a museum, so it was a public institution, but privately owned actually. So it was like rented out to the museum, and then it was closed, and then now it's again a private house. So it has been sold to a private owner. So yeah, so that's this is something definitely that it needs to be taken into account, of course.
Cool, thank you. Okay, last chance for anyone watching to leave any comments in live chat, as we're about out of time. But if any comments appear in the next few seconds, we'll see them and can respond to them. Does anyone else have anything in the meantime they want to round up with, finish off by saying?
Well, thank you for presentations and the tutorial. It was very nice to be here, and I hope it's going to be useful also for the people watching it and who is going to watch it later on as well.
Great.
Yeah, I would also like to thank you for the invitation, and I hope it will be understandable and easy for the students, the tutorial. Yeah.
Great.
Yeah, thank you both for joining us today. I learned a lot, so I'm sure everyone else did too. So yeah, I really enjoyed it. Thank you.
Yes, thank you all. And as I said at the beginning, this is the last seminar in this semester. The next semester, the summer semester, starts in about 4 or 5 weeks' time, and will be advertised in all the usual places, and will also appear on this YouTube channel. And that's the summer semester of Synoikis DC, which is primarily organised by Monica Berti, and I'm helping a little bit with next semester as well, but she's doing most of the lifting. So so we all look forward to that, and so thank all of you again, and see you all in the future.
Thank you.